So I have been playing with Sonarqube here on my 10% time. Sonarqube is a tool I've used before to try to improve code quality. It's a wonderful tool that does tons of different analysis, and most of all, it consolidates all the metrics about quality we have in a single place and gives a nice view over time of that. I'm going to make it very short so we can have questions. I took a few random projects and tried to analyze them a few times. And let's see how that looks. First thing that is interesting in Sonarqube is the technical depth. There's an estimation for each of the violation we have of the time it takes to correct it. So we see zero search is not too bad. Let's see in details. Overall, we have less than 2% of technical depth. Sounds good. And I can go into the details to see what kind of things I need to fix. So there is a UI, you can play with it as much as you want. We see what kind of exceptions we have, what kind of things we should correct. The rules themselves have not been tuned yet. It probably reports a ton of stuff that is just different style than what we use, but that's something we can improve over time. One of the nice thing about Sonarqube is we can see how our quality evolves over time. If it loads, yes. So I did a few analysis over time. We see that, well, quality is not improving compared to our current metrics. We can see for each kind of issue how it is evolving over time. So that's a nice thing that most of those tools don't give us. Last thing I'm going to show is the quality gates. What is important if we want to improve our quality is make sure that we have a clear warning if things degrade. And compared to other kind of tools, we have more flexibility on what we think is degradation of quality. So most of the time, we have a large code base that has a lot of violations that we don't care about because they are in production, they work. It does not make sense to invest in fixing them. So we can have rules like critical issue since the previous version is 0. So we are not allowed to introduce new critical issues. We can have stuff like code coverage on new code has to be at least 80%. It's really hard to have a gate that says all of your code needs to be covered at least 80%. We have to stop for 6 months and just writing tests. This does not make sense, but we can focus on the new code that you're writing. So that was the very, very short overview of Sonarqube. I have some documentation that is linked in the Etherpad. You can ping me if you want more details, if you think that's something that makes sense to dig into more. If you want to try playing with it, there is a link to the proof of concept instance. It's going to crash. You're going to lose the configuration, the metrics you have there. Don't trust it, but play with it and let me know. Questions?
And I'd ask if people do have questions, if they would take it to the Etherpad. And Guillaume, if you could answer questions in line in the Etherpad, in the interest of kind of being able to move to the next demo. So we were getting a little bit of echo. It looks like it might be the Wiseman account that is kind of intermittently sending audio. I don't know if there's anything we can do to sort of mute that, but maybe the point is moot right now because I think Max is up next and he's on site.
Hello?
We hear you.
Excellent. So I started to use my research time for diff improvements, and most people don't know, but MediaWiki core has two different diff implementations in PHP, and the non-default one that's called WikiDiff 3 is several times faster than the default implementation on diffs that are actually slow to generate. However, it doesn't guarantee the same implementation details. So I decided to build this thingy to do a more scientific comparison. So I loaded a million diffs from English Wikipedia. Roughly on 5% of them, the two implementations are different. So let's take a look at what's going on. So here you see two diffs from differing algorithms. They're intentionally positioned randomly, so until we look like at the vote URL, we don't even actually see which is which. So and depending on which diff you like, you can vote at which point you get a different diff to compare. So far, from my own comparison, the two algorithms seem differ in only non-obvious ways, so that you generally can't tell which of them is better. I will show it to people if they agree. Then we can proceed to, use a more fast diff engine by default in MediaWiki. That's it.
Thanks, Max. Is it okay if we mute the room while remote participants are speaking?
Yeah, sure.
Okay, cool.
Hello.
Looks like Trey is up next.
Hello. Hey, Max.
Hi there.
Quick question from the room. There was a bunch of us who are a little bit confused about why there's any ambiguity around how a diff would appear.
So historically, the second diff engine was introduced by a Summer of Code student ages ago. And that student wasn't sure about his creation, I guess. So it needed a certain configuration change to be enabled, and I would suspect that nobody actually used this setting, so it's largely untested.
Thanks. I thought it was somewhat deterministic. That I guess that's where the confusion is. In the sense that you make an edit, there's only one way to show.
Yeah. So the final result of this my work would be to choose which of them should be used, and the remaining one will be thrown away.
Yeah, if I could just add, there's actually a lot of different ways to show a diff, depending on how advanced the interline diffing is, or if it does interline diffing at all. It's just line based. There's a lot of different ways actually. So It's not totally deterministic. I mean, you could have two ways of showing the exact same information.
So actually, right here we are talking about an underlying diff algorithm that searches for difference. Then you can put a different formatter on it, like you can render it as side-by-side diff, like on this picture. You can do a unified diff, like command line diff does, and the mobile front end has inline diff. But they still use the same algorithm internally.
Okay. I think Trey is ready to go.
Yep. Can you guys hear me?
Yeah.
Okay, let me share my screen.
Yes, we can hear you.
Okay, you guys see the Relevance Forge information on the screen?
Yes.
Okay, great. So I was going to give an update to the improvements we've made recently to Relevance Forge. This originally started off as Relevance Lab, but somebody was unhappy with so many things named Lab, so we had a little vote and decided to rename it Relevance Forge. It's the same basic thing. It allows us to gauge the effectiveness and impact of proposed changes to the search and test them in the lab before putting them in front of users. So I'm going to show a couple of examples. Here are some of the reports that we get. Basically, you can specify the host and the wiki and a set of queries that you want to run, and then various search parameters, and you have a baseline, and then you have a delta, and you can compare the two and see what's happened. And like I said, get an idea of the, excuse me, get an idea of the impact and the magnitude of the change that you're proposing. So right here I have a small sample. It only has 9 documents. Let me just go up there to the top. So we have 9 queries here, and we're comparing them using the, whether we use the all field or not, which isn't really important, just as an example. And in this case, we have 9 queries that we think should have a change. And so that's sort of my test set to make sure that I've implemented the change correctly and configured everything properly. You can see here that we can see a change in the 0 result rate. Originally, it had 11%, which is 1 out of 9. And then the 0 result rate afterwards is 0. We can also define these different metrics that we are interested in the top number of changes, the top n changes, 3, 5, 20 here, for example, whether we include sorted or unsorted. So, if the top 3 results move around, that isn't really, in some sense, that isn't really as different as if new results have moved into the top 3. So that's the sorted versus unsorted. Let's see. So one of the things that we've added recently is these charts. The charts on this small sample aren't great, so I'll look at some of those in a minute on another sample that's larger. But you can see here that, sorry, there's an echo. You can see here that there's how much is different here. This is a really big change. It affects pretty much everything, but also these particular 9 samples were chosen to have the change to be affected. And so we get a little summary here of the how much has changed in the various metrics that we're looking at, and then we also get examples. So we have one query here that changes in 0 results. Here's some queries that have changes in the top 3. In this particular case, you can also specify the number of samples that you want examples for a particular change. I'm looking for a particular one. Here we go. All right, so we've got the diff page that we're linked to off of that report and shows us information about the queries. The queries don't have to be the same. In this case, they are. And we have the number of results, the baseline number of results in the delta. In this particular case, this is a weird thing that it takes the Chinese characters and actually searches for individual characters rather than searching for it as a single word. So we get additional results here. This isn't too interesting. Let me jump over here. Here's another one. We have the query is Shifu. Same number of results, but they're ordered differently. We do an automated diff and does automated alignment of the the results here, and we can see the one that's just in the black, the white square with the black border is the order hasn't changed. So number 1 and number 2 haven't changed. Here in the delta, number 3 has moved up 5 positions. So we have this little 3 says moved up 5. It didn't get aligned. Here, number 6 has moved down 2 positions. Again, the alignment's not there. The automatic algorithm chose to align number 3 and number 10. So it's 3 originally moved down 7 spots to number 10. In any of these cases, though, you can click on the number and see the before and after. In this case, right now, I'm only showing the difference. The only difference I have between them is the score. The snippet text is the same. But if there was additional information that was in the results, in the JSON that comes back, we would see that as well. Real quick. The other thing is we see these ones that are bright green are new results that weren't in the old results in the top. These are top 20, so they weren't in the top 20 before. And the dark red ones are ones that were removed from the results, so they're no longer in the top 20 anywhere. And this lets us, get a sense, be able to review the changes that we've made. Like I said, this is a really big change. It really shuffles everything around, which is why I wanted to demo with it. It's a little harder to interpret what's going on just because there's such a big change. We can review these changes, look at the top results, and see whether or not we think that the change is improving things or not. Real quick, I'm going to go back to the report. After we have a change and we think that we like it, we can run a regression test on a large random sample. So this is a 1,000 random queries from English Wikipedia. And we can see that this is a really huge change because it affects 60%, over 60% of results in the metrics that we're looking at. So there's a lot of changes in the top 3, which is kind of a surprise. Here we have the charts that I was talking about before. Let me find a good one. Yeah. So here we're looking at the top 20 top 20 unsorted results differ. So this means that changes have been introduced, new results have been introduced into the top 20. We can see here, we got some charts here. This one shows us the number of queries that had this many results change. So the vast majority, the most common result is 0 because there's about 40% that didn't have any change. Then we can see the number of changes in the rest of the histogram. Also, sometimes the 0, and for smaller scale changes, the 0 results totally overwhelm everything. So I also have the same chart, but without the zeros included, just so we can, it affects the scale. We can have a better idea of what's going on. So you get an idea of the distribution. If it changes 50% of the queries, but they each only have one additional result change, that's not as big a change as 10% of the results have all the top 20 changed. And this graph lets us get a handle on that. I think that's all I've got. There's some other tools that are in the Relevance Forge that we've been working on. There's a tool that lets you optimize configuration options by running a brute force search over the parameter space. We've got some tools that let us dig into individual queries and look at the results, the scoring, and some other tools in there. But I just wanted to show the report for now, I think. If anybody has any questions, I will answer them in Etherpad.
Thanks, Trey. Okay, Aaron.
Okay, I'm just trying to set up my Chrome extension. Ah, shoot. Apparently your extension doesn't get enabled in an incognito tab. So maybe let's skip me and I'll try and get set up in a not incognito tab and get the extension going.
Okay. Yuri, are you able to go?
Well, let's see. All right, this is me. I wonder if, yep, everyone can see me. My name is Yuri, and I'm going to demo something I did during the hackathon in Israel. Well, let's see if I can actually keep this thing on screen, because I know there are a lot of people having issues with that. Share my entire screen. Share. Everyone see it? Need some feedback here?
Yes.
Excellent. All right, so my little experimentation was with storing structured data on Wiki. We all want it for the past 15 years, so I tried to take a stab at that. So this is a very simple data namespace test.json. The content of this nice little thing is like that. Of course, we can develop a much better user interface using some JavaScript, and that is a big to-do. But this is not all, obviously, because we also want to do something like this, a data Israel GeoJSON, where we have a nice visualizer with a map showing what that JSON represents as. And if we look inside, it's also a JSON with lots and lots and lots of data points. But that's not all. We can have tabular data. And in this case, just 2 columns, but this is more than enough for the demo. Labels, values, sortable, obviously. You know, you have to be sortable, although every other line is kind of broken yet to do. But it gets stored, again, as a JSON with some headers information and all the rows. Obviously, eventually, hopefully, Wikidata data types will be supported as well. But for now, this is a pure JSON. Maybe we'll have some optimizations, and I'm sure we'll have some importers and exporters to copy-paste CSV and TSV directly into here, but it gets automatically converted into JSON. And just to show what's possible, instead of doing something like this, a pie chart current, we just supply some values in some either JSON or some other crazy way. We can do something like this, where you say pie chart, and then you just point it to the page that contains the data you want to plot. And there's 2 pages currently, and they plot differently. And I am done. Thank you very much.
Thanks, Jerry.
Let's see how I stop the sharing. There.
Okay. Aaron.
Yeah, I'll give it another try now. Yeah, it's still not registering that I have the extension installed, regretfully. So I might have to give this a try next round.
Aaron, you also...
Okay.
Aaron,
does anybody else have anything they'd like to share?
Download the application, the BlueJeans application, and join the meeting from there and probably get it to work. But it's up to you.
Yeah, I just think that this is likely going to take a little while to get set up.
Okay. Yeah, maybe next go around. Aaron, if you want to do some kind of recording, we can try to set something up too and post it along with this video.
Okay, thanks.
Okay, cool. Catch you later. Thanks, everybody.